Good morning, everybody. So today, for our e-learning lesson, I would like to clarify what we learned yesterday about midsegments of triangles. Our objective, you're going to learn the definition of a midsegment and medians. We're not going to do medians today. You're going to be able to use the properties of midsegments to find unknown measures of triangles. So a midsegment, as we learned yesterday, is a line that joins the midpoints of any two sides of a triangle. Remember the two observations I wanted you to figure out? It's parallel to the third side, and it's half the length of the third side. So here, M and N are the midpoints, and we know they're midpoints because they cut segment AB and segment AC into two equal congruent parts. So therefore, MN is the midsegment. It is half the length of BC, and since it's parallel to BC, that means that angle M is congruent to angle B, and angle N is congruent to angle C because they're corresponding angles. Every triangle that we draw, since it has three sides, also has three midsegments that form a midsegment triangle. So our first example, we'd like you to be able to find the unknown lengths. So take a look at our triangle. D, E, and F are the midpoints. Now, my advice, I'd probably start marking this thing up. Okay? Find the following lengths if D, E, and F are the midpoints. The first length, AC. Well, DF is the midsegment associated with AC. DF is half of AC, so if DF is 4, AC is 8. For DE, it's half of what BC is, and if FC equals 5, BF equals 5, therefore DE would also be 5, because BC would be 10, and half of that would be 5. DB, well, it's associated with 3, so AB would be 6, and DB would be half of that, 3. And then finally, BF, well, it's the same as CF because F is the midpoint of this segment, so it's 5 as well. I'll also expect you to be able to find variables, such as this problem. Solve for x if A and B are the midpoints. Well, AB, the midsegment, is half of the third side, 34. So we can write the equation that 3x minus 1 equals 17. Why 17? Because it's half of 34. And then we're just doing algebra from here. So we'll add 1 to both sides to get 3x equals 18. We'll divide both sides by 3 to get x equals 6. Take a look at a second example like this. Now I did this one in two different ways. Knowing that I know the midsegment is 5x minus 1, which is half of 58. So 5x minus 1 equals 29. Add 1 to both sides to get 5x equals 30, and thus x equals 6. Notice how I did it in blue. Because sometimes if you take half, particularly if you take half of an odd number, you're getting into fractions or decimals. So it's sometimes easier, instead of taking half of the third side, to double the midsegment. So the midsegment, half of the third side, so the third side is double the midsegment. So I double 2 times 5x minus 1. Gives me 10x minus 2 equals 58. Adding 2 to both sides gives me 10x equals 60, and x equals 6. Notice either way, I get the same answer. So sometimes it's easier to take half if we get a nice integer, but if taking half of this is going to cause a decimal or a fraction, you're better off to double your midsegment, because doubling tends to get rid of decimals and fractions. Take a look at our last example. Solve for the unknown variables. This is a midsegment. So I can take half of 8x minus 2 because it's still going to be friendly numbers. So 2x plus 1, the midsegment, is half of the third side. 2x plus 1 equals 4x minus 1. So we'll add 1 and subtract 2x to get 2 equals 2x, and thus 1 equals x. Now, to find z, since this is a midsegment, that means this is a midpoint, and these two pieces are congruent. So 3z has to equal z plus 22. We'll subtract z on both sides to get 2z equals 22, and thus z equals 11. And that, ladies and gentlemen, will end today's lesson.